Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 1111. Please like and share the channel. To receive a notification when I upload new content, please subscribe to the channel and click the alarm bell icon. Please leave a comment if you enjoy this video or you have anything you'd like to share with me. In the description below the video, you will find a link to print the math handout I'm using. In this video, I'll be going over problem number 12 from the Chapter 8 Combination Circuit Math Handout. So we see our circuit here. We have two series parallel strings. Branch 1 has R1 and R2. Branch 2 has R3 and R4. So the first thing that we're going to do, since this is a basic combination circuit, and it is not a random unknown, as we're going to try to solve for RT. So as I'm looking at the circuit here, I notice that R1 and R2 are in series with one another. R1 and R2. And R3 and R4 are in series with one another. R3, R4. So I'm going to redraw the circuit, and this is one of those circuits that I have to redraw in order to be able to calculate. So whenever I do my redraw, I'm going to redraw it with two resistors in parallel. I'm going to have an R1/2 of 300 ohms, which is R1 plus R2, and I'm going to have an R3/4, which is R3 plus R4, giving me 900 ohms. Now I have two resistors in parallel with one another, so if I use the reciprocal formula, which we use for resistors in parallel, I can find RT. So looking at the calculator, I'm going to go 1 over under 1 over under, put in the value of 300 ohms, scroll over, plus 1 over under, and 900 ohms. It equals, and that gives me an RT of 225 ohms. So I can fill in that blank now. Anytime I can get 2 out of 3 going horizontally across, I can solve for the third. I'm going to save power till last. So I've got 36 volts and 225 ohms, 36 over 225, and that gives me my IT of 160 milliamps. Now the next thing that I have to do in order to solve for this circuit is I'm going to focus here on drawing B. And I'm going to take my VT of 36 volts and I'm going to apply it to branch 1. So I'm going to have a V12 of 36 volts. I'm going to take, again, my VT of 36 volts, and I'm going to apply it to branch number 2. Because the total amount of voltage that R1 and R2 will consume will be 36 volts. The total amount of voltage that R3 and R4 drop will be 36 volts. So I can apply the 36 volts on branch 1, I can apply the 36 volts on branch 2. And that will give me the total current that will flow through both of these resistors. So let's do that. 36 over 300. That gives me 120 milliamps. So my I12 voltage, current, the amount of current that flows through branch 1 will be 120 milliamps. I'll take the 36 volts divided by 900 ohms. And that gives me 40 milliamps. So the current flowing through branch 2 would be 40 milliamps. Now if we go back over here to our first drawing, our original drawing, when the current comes from point A and it reaches point B, and it turns at point B and begins to head towards point E, whatever current leaves point B, all of that current must flow to point E, because there's nowhere for it to exit once it leaves B headed to E. The remaining current will leave B, go to C, go from C to D, and back to E. Once it leaves point B, there's nowhere for it to exit. It all has to flow through 4 and then 3 and then back to E. So what this tells us is that whatever current leaves point B and turns and starts heading up branch 1, the same amount of current will go through R1 and R2. Because from point B to point E, you have a series circuit. So as the current is coming out of our voltage source at point A, and it reaches point B, and it turns and it begins to go this way, the amount of current that will flow from B to E is determined by the total resistance in that branch. When that current turns at point B, it will see the resistance of both the resistors. This is where we get 120 milliamps. So 120 milliamps will flow through both R1 and R2 because it has nowhere else to go. The current that continues on from point B to point C and up through point D, all of that current will be the same amount that goes through R3 and R4. So R3 and R4 will both be 40 milliamps. When we did our calculation on our second drawing, we were determining the amount of current that flows through branch 1 and the amount of current that flows through branch 2. Once we get this value here, we know that I12 will be the current that flows through R1 and R2. When we get this I34 value, it tells us the amount of current that will flow through R3 and R4. And how did I get that again? I took the total voltage that we had for the circuit and I applied it to branch 1 and branch 2. I got the R12 value by adding R1 and R2. I got the R34 value by adding R3 and R4. So I had the R12 value, had the R34 value, then I took VT, applied it, divided it by 1,2, that gave me my I12. I took the VT value of 36 volts, divided it into the R34 resistance, and that gave me the current of 40 milliamps. So now I've got my I1, I2, I3, and I4 value. I've got 3 out of 4 for V1, V2, V3, and V4, so now it's just a matter of Ohm's law. V1 is equal to I1 times R1, so 120 milliamps times 100 ohms. 120 times 10 to the negative third times 100. That gives me 12 volts. 120 milliamps times 200. I just scroll up here and change this to 200. That gives me 24 volts. If you put the 12 volts plus 24 volts, that's 36 volts. So these two resistors combined will consume a total of 36 volts, just like we applied. Let's do the values for 3 and 4, and they will add together and total 36 volts, just like we applied in our second drawing. So we take 40 milliamps times 680 ohms, 40 times 10 to the negative third times 680 ohms, gives me 27.2 volts. 40 milliamps times 220 ohms gives me 8.8 volts. Now I can solve for power. I'm just going to use the basic power formula. PT is equal to IT times VT. P1 is equal to I1 times V1. P2 is equal to I2 times V2. P3 is equal to I3 times V3. And P4 is equal to I4 times V4. The way that I can check my work, if PT, if I have the same value of PT when I take IT times VT, and I take and add P1 plus P2 plus P3 plus P4, if those both ways of calculating that gives me the same value, that's a good way for me to check my work. So the key to working this circuit, and don't forget about the steps over here, I want you to write down these steps, put them where you can't see them, try to rework this circuit, and if you get stuck, you can look over at the steps and see where your next step is to continue. The key to working this circuit is to redraw, and then to apply your VT to each branch. Your R value comes by adding these two, this R value adding these two. As long as you can remember to apply the VT to each branch, that'll give you the current for each resistor, and then you can solve for your voltage.